Okay, so we're going to start with wave energy and merge it together with sound because they're closely related. Alright, so bring these notes with you next class. Alright, so let's start with the definition of a wave. It says a wave is a traveling disturbance that carries energy from one place to another. So it's important to notice that it says it carries energy. It does not carry matter. If you think about ocean waves, it does not push you forward unless you're in the braking area. All it does is lift you up and set you down. It does not move you forward, okay? Otherwise, boats and everything else that's out in the ocean would all be washed up ashore. A vibration is what's needed to give the wave energy. All right, a medium in this sense is the matter or the substance that the wave is moving through. Your example, water moves through ocean waves. Sound waves move through air, so air would be the medium. Waves that need a medium are mechanical, and waves that do not need a medium are electromagnetic. Mechanical and medium both start with M. That might help you remember. Okay, the parts of a wave. On the next few slides, you're going to see pictures. I would write out the definition, draw the picture, and label it as well. You've learned this before. Okay, the highest point of a wave is called the crest. So if you were surfing, you would surf on the front part of the crest, the top front. The lowest point of a wave is called the trough. Think about when you're standing out in the waves, maybe at Ocean Breeze or Water Country USA. When it's really high and you have to jump up. In the building, please dial 62004. Miss Danzel, if you're... Sorry about that. Okay, so whenever it rises really high, that's the crest, and then it goes really low, maybe down below your waist. That would be the trough. Okay, so the lowest point of a wave is the trough. An amplitude is from rest to crest. Rest, just so you understand it, is when Ocean Breeze or any water park turns the waves off. Where the water sits when it's not moving is the rest. Okay, so from that point to the crest, to the highest point, or from the resting point down to the bottom of the trough would be the amplitude. A wavelength is from crest to crest. Wherever you start on the wave, it's where you end on the next wave, and that would be your wavelength. Make sure you're writing all of the definitions down. And then here, let's look at some pictures. Alright, so in this picture in the red, you can see the wavelength is from crest to crest. I could also draw one from trough all the way over to this trough if I wanted to. Amplitude, you can see, it's from the resting point. If the water were to stop moving, it would be in the middle here. So from the resting point up to the crest, or from the resting point down to the trough, those would be amplitude. Frequency. If I said to you, how frequently do you go to Busch Gardens? Or how frequently do you go to the beach? I'm asking you, how often do you go? Frequency means that. It's how often does a wave pass a certain point. Okay, so the number of complete waves per unit of time. How quickly is it moving? How slowly is it moving? It's measured in hertz, named after Heinrich Hertz. And it says 1 hertz equals 1 wave per second. So if we're looking at this picture, I would count the waves here. So I would literally count from crest to crest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 waves have gone by. We're going to assume it's 1 second, so I would say it's 12 hertz. In this bottom picture, only 2 waves have gone by. So I would say it's 2 hertz. Make sure you're looking at the pictures and not just listening for that one. A transverse wave. This one moves up and down at right angles. If I had a jump rope handle and you had the other jump rope handle, and I jerked my arm up and sent the wave toward you, that is a transverse wave. If we sat down on the ground and put the jump rope on the ground and we just swayed it back and forth but still leaving it on the ground, back and forth, side to side, that would be longitudinal. A compression is when the particles in a wave are squished together, they're compressed. And a rarefaction is when they're spread apart. So next class, I'm going to get out a slinky and I'm going to show you what I mean. If you have a slinky, have somebody grab the other side, squeeze together about 5 of the springs and let it go. And what you're going to see is that squeezed 5 are going to literally, it's going to look like, it's just the energy, but it's going to look like they move all the way over to the other person and come back. The compression, the energy that you just caused, is going to move all the way across and come back. And when they're all spread out where it doesn't look like it's moving, those are rarefactions. This is probably where you should stop and then get the rest next time. Okay, but in this picture you can see this transverse wave is moving up and down in this direction. And we would say that there are 3 waves here, 3 hertz. You can see again they're pointing out amplitude, wavelength is crest to crest, trough to trough would be another wavelength. Wave height would be, just so you know, crest to trough. How high exactly is the wave from the lowest point to the highest. Okay, longitudinal waves. You can see in this picture, this is your compression right here, where it's all squeezed together, and then the rest of them are rarefactions. Okay, your last type of wave, a surface wave, is when it's moving in both ways. And my best way to explain a surface wave is this example. It says ocean wave moves between both ocean and air. So it's moving transversely in the water, but longitudinally through the air. All right, the speed of a wave is the wavelength multiplied by the frequency. So how big is it multiplied by how fast it's moving? It says a wave with a frequency of 5 hertz and a wavelength of 2 meters is moving 10 meters per second. All I have to do is multiply the 2 numbers given. The medium determines how fast it's moving. Believe it or not, things can move much faster through solids than they can through liquids, and even slower in gases. Okay, there are a few wave interactions I need you to know. A reflection is when it bounces back. It hits a flat surface or a plane and bounces back at exactly the same angle. Okay, reflection comes back at exactly the same angle, and that's why you can see, or you might hear an echo. That would be an example too. And it comes back exactly the same. The law of reflection says exactly what I just said, that the angle of incidence, it going in, is equal to the angle of reflection, it coming out. If it goes in at 90 degrees, it comes out at 90 degrees. Here's a good picture showing, so the wave comes in at this angle, comes out exactly the same angle. Refraction is the bending of waves due to a change in the speed. So light is traveling at one rate, and then when it hits water, it actually slows down and it bends. Diffraction is the bending of waves around an object. Think about a boat or a log, and the water waves have to kind of bend around it. Here are 2 pictures. Refraction makes the pencil look like it's broken or bent. And then this is diffraction of light beaming out from on the other side of a cloud. Interference is when 2 or more waves hit at the same time. If the 2 of them hit and make one bigger wave, it's constructive. They're building something, constructing. If the 2 hit and destroy each other, you get destructive interference. Here's a picture of interference. So wave A is this size, wave B is the same size. The 2 join and now are even bigger. The last thing, a standing wave. If you were holding a piece of elastic, a rubber band that you had cut the end so it's straight, and you wound it up, swung it around, and then pulled it tight, you would see a standing wave. It's hard to describe me saying it. I'm going to need to show it to you, so next class I will show you what a standing wave is. So just write this definition. Make sure you're labeling the nodes as like the little hills, and the antinodes would be like the valleys in between. Or I'm sorry, the nodes are the valleys. Antinode is the hill, node is the valley. All right, I will see you guys in class. Have a good weekend. Bye.